Welcome to online lecture series in organic chemistry. In this video, I am going to discuss the organometallic compounds of main group elements, that is S and P block elements. Now in last video already I discussed what are the organometallic compounds, and you know that organometallic compounds, these are the compounds in which metal atom or less electronegative atom than carbon is directly bounded to carbon atom. These are called as organometallic compounds. Now in this video we are going to discuss the types of organometallic compounds and their general characteristics. On the basis of nature of metal carbon bond, organometallic compounds are classified into three types, that is ionic organometallic compounds, sigma bonded organometallic compounds, sigma bonded or covalent organometallic compounds, and multi-centered electron deficient organometallic compounds. So these three types we will discuss one by one. The first type is ionic organometallic compounds. In these ionic organometallic compound, there is a electrostatic force of attraction between carbanion and highly electropositive metal cation. Actually, these ionic organometallic compounds, how they are formed? By the formation of bond between carbanion. Carbanion means carbon bearing negative charge. There is a bond between carbanion and highly electropositive metal ion, and between these two species there is a electrostatic force of attraction. Normally alkali metals, alkaline earth metals, lanthanides and actinides form these types of ionic organometallic compounds, because alkali metal, alkaline earth metals, these are highly electropositive, and lanthanides and actinides are also metals, and therefore highly electropositive metals, that is S block and F block elements, they are able to form ionic organometallic compounds. Now next important point is, most of the ionic organometallic compounds are colorless salts and they are in solid state. So they are colorless salt like solids. Most of the ionic organometallic compounds are soluble in polar solvents. They decompose on heating. Then most of the ionic organometallic compounds are extremely reactive and kinetically labile. Now when carbanion in this organometallic compound is unstable, then resulting ionic organometallic compounds are highly reactive and labile. For example, organometallic compound formed between sulfur and carbanion. This is highly reactive organometallic compound, ionic organometallic compound, and when carbanions are stable, their resulting ionic organometallic compounds are less reactive. For example, Ca2 plus C6H5 minus. So this type of organometallic compound formed by alkaline earth metal, it is ionic and it is less reactive, because here carbanion, it is stable and resulting ionic organometallic compound is less reactive. Now second important type is sigma bonded covalent organometallic compounds. The organometallic compounds involving metal carbon sigma bonds are called sigma bonded covalent organometallic compounds. Normally in these sigma bonded covalent organometallic compound there is a two centered two electron bond. In most of the compound the covalent bond is two centered two electron bond. So normally these types of organometallic compound contain two centered two electron bonds. So most of the non-transition elements and specifically group 12 elements, that is zinc family, they form the covalent or sigma bonded organometallic compounds. Now here in this case, or in sigma bonded covalent organic metallic compounds, polarity of metal carbon covalent bond, it depends upon difference in electronegativity between metal and carbon. Greater the electronegativity difference, greater is the polarity. Actually electronegativity of carbon is fixed, metal is different in different organometallic compounds. So greater the electropositivity of metal, the greater is polarity of resulting sigma bonded covalent organometallic compound. Next important character is many alkyl organometallics exist in polymeric state. For example, trimethyl aluminum exists as a dimer. Then the organometallic compounds such as tetramethyl lithium, dimethyl zinc, trimethyl boron, these are inflammable. The tetramethyl silicon, tetramethyl tin, these sigma bonded organometallic compounds burn in air on heating. When these are heated in air, they burn. These organometallic compounds are good reducing agents, and specifically trimethyl aluminum undergoes hydrolysis. When trimethyl aluminum is added in water, there is a hydrolysis and there is a formation of aluminum hydroxide with the evolution of methane. So this is about sigma bonded covalent organometallic compounds and characters of these compounds. These are the remaining or any other examples: diethyl magnesium and dialkyl beryllium. All these are sigma bonded covalent organometallic compounds. Now third important type is multi-centered electron deficient organometallic compounds. In these organometallic compounds there is a multi-centered bond, that is 3-centered 2 electron bond. There is a 3-centered 2 electron bonds, and these multi-centered electron deficient organometallic compounds act as a Lewis acids, and they usually occur in polymeric form. For example, trimethyl aluminum exists as a dimer. This is the dimer of two trimethyl aluminum compounds. It exists in dimeric state. And aluminum, methyl aluminum, this is the bridge, one bridge. There are two bridge, aluminum, methyl aluminum, this is one bridge, aluminum, methyl aluminum, this is the second bridge. So bridging bonds are normally 3-centered 2 electron bonds. This aluminum, methyl aluminum, this is 3-centered 2 electron bond. 3-centered 2 electron bond. And here important thing is trimethyl aluminum exists as a dimer, and there are two bridges, and bridge bonds are 3-centered 2 electron bonds. Another example is dimethyl beryllium exists as a polymer, and there are different beryllium methyl beryllium bridges, and beryllium methyl beryllium, this bridge, it is the tricenter or three center 2 electron bridge. Another interesting example is MCS3 CP2 twice, where Cp, it is a cyclopentadienyl species. Eta 5 C5H5 means its heptacity is 5. So pentaheptic ligand, and this is cyclopentadienyl ligand, its heptacity is 5. And M, it is any metal like yttrium, dysprosium, holmium, erbium, etc. And this is the structure. There is a metal, methyl metal, as a 3 center 2 electron bridge. 3 center 2 electron bridge. And this is about the multi-centered electron deficient organometallic compound. So in this way, there are 3 types of organometallic compounds. Ionic organometallic compound, where there is an electrostatic force of attraction between carbanion and highly electropositive metal cation. In case of sigma bonded covalent organometallic compound, there is a normal metal carbon sigma bond, which is 2 centered 2 electron bond. And in case of multi-centered electron deficient organometallic compound, there is a multi-centered, that is 3 centered 2 electron bond. And these multi-centered electron deficient organometallic compounds, these usually occur in polymeric form and act as a Lewis acids, and these are the examples.